again, we changed a few technical parts of the specification also, and decided to go with a new name at the same time. So it's called CBFS. That's, of course, coreboot file system. And it's a file system for the flash chip. So the flash chip where you have the firmware is made up of a bunch of files. That's also the way all the factory BIOSes work. They have some simple kind of flash file system too. CBFS has a fixed location boot block, which is at the end of the file where the reset vector is supposed to be. It's currently also fixed size, 64 kilobyte, but there's some work to be able to have a dynamic boot block, making it just a couple of 100 bytes in size. Because if you have a smaller flash chip, it's nice to have those extra kilobytes, and even if you have a large flash chip, maybe they're just what you need in order to fit that nice payload in there. Besides the boot block, there are the coreboot files. So coreboot really is made up of two files inside CBFS. The first one is the ROM stage, which is the part running, setting up caches RAM and setting up the RAM initialization. We're doing the RAM initialization. And the next part is coreboot RAM, which does all the thorough device enumeration, finding out, scanning the system completely for all the devices that are connected and configuring them and doing the resource allocation and so on. Besides that, there are the payloads. Of course, payload or payloads if you have many. And into the CBFS you put the VGA BIOS as well if you have one. And you can also put option ROMs if you want to use those with CBIOS. We had a Summer of Code project with, well, 3 projects in Summer of Code. One was the GeoDelX VGA BIOS project, creating a VGA BIOS ROM for GeoDelX, which is open source. So the ROM is open source. There was a VGA BIOS from AMD, but it was, I don't know exactly why, but I guess they had licensed some parts of it from someone else, and they weren't allowed to open source it, even if they wanted to. And that project, anyway, it was finished, it's working. There are patches for the CBIOS, VGA BIOS. There's a VGA BIOS inside CBIOS, or part of CBIOS. Another project was a USB option ROM to be able to boot from USB devices on systems where you don't have a bootloader which supports a USB natively, and I only know of Philo which does. So this seemed like a good idea. It would be nice to use with CBIOS, of course. It would also be nice to use if you have an older system without USB support in the factory BIOS. You could use this, somehow get it to initialize in the system. There are a few ways, and be able to boot from USB also on really old mainboards. Unfortunately, this project, it wasn't so successful. Maybe it was the wrong approach. And we have to rethink that a bit, how to best be able to boot from USB in all the cases. And then we had a comeback, or a sequel to the last year, the project from last year's Summer of Code called AVAT. Cristi Magherosan from Romania, he worked on getting coreboot to do all virtual all the time, or getting the PC to do that. By having coreboot start a Linux payload, a Linux kernel payload, which together with KVM tools go into the flash chip, so that you have the basic hypervisor in your system running directly from boot time, and any operating system kernel that you're running, or any operating system image that you're going to run in the system, will be virtualized using KVM. And he had some issues last year running into how UClibc implements thread local storage, and finally that was solved this year. So it's actually working, and it's really nice. It requires a bit bigger flash chip though, but it works, and it's a really nice project, I think. We had some vendor developments this year. AMD engineers, they worked on coreboot support and developed coreboot support for the AMD RS780 and SP700 chipset products. It was finished sometime this summer, maybe even late spring, but I guess the last bugs fixed in the summer, as we understood. And then the code needs to go to the AMD legal department for review before they can release it, because it's going to be open source, and they need to check if it's okay to release this code. And it's still there, unfortunately. Now, next year, in a few months, AMD are going to come out with a next generation chipset, the RS880 and the SP800 combination. And it's, of course, unfortunate that once more we don't have the code until the chipset is nearing end of life, but what to do? They released documentation really fairly quickly, even before they released the code, or even before they developed the code themselves. But unfortunately, it's not really helpful enough. The documentation from vendors never really is. You need a lot of extra knowledge, which typically is only available from the FAEs, the field application engineers working for the vendors, and usually open source projects don't have the right connections to reach these engineers. But we're working on that as well. AMD is really a good player. I think they're participating on the mailing list and are being friendly. I'm just sad that the code has been stuck for so long. When it comes to VIA hardware, we got some code contributed by the OLPC, the One Laptop Per Child project. They sent us code for the VIA VX800 and the VIA VX855 chipsets, which the 855 I think was released this summer. So that's really nice, and also the Nano CPU support. It's the typical open source vendor tragedy where they work parallel with the project instead of working together with the project. So when they release the code, it's based on 3 months old trunk. So this code base needs to be sort of unified for the VX800 and 855 and then forward ported so that it can be merged with the current trunk. And on the Intel front, we don't really hear much from Intel themselves, but we've heard from a couple of companies that are working on Atom and Intel 945 combination platforms. They've sent a couple of questions asking about, well, my payload seems to not be running right, and they haven't sent any code, so all we can say is, well, check memory in it. It's probably the problem. So hopefully they will also release some code eventually. Another fun thing that happened in 2009 is we got the cover of Linux Journal magazine and a really good article in there about coreboot and how you can get started running coreboot in QEMU. So that's the October issue. I think you can find the article online by now. And we're going to have a dev room at FOSDEM. That's going to be fun. And I don't know, maybe a coreboot conference. How many of you guys would be there if it was in Northern Europe somewhere? So, okay, a few hands, 4 or 5. It's good. Related projects, Serialize. This was an idea that a couple of guys had during the Embedded World, we discussed it anyway a lot during Embedded World in Nuremberg in March, and 1.0 was released in June, and 1.5 was released in November. This is just a very small program running on the target platform, a ROM shell, which accepts commands over a serial port. Then there's a QEMU part of Serialize running on the host system and communicating with a ROM shell. So you use